In these examples, we'll look at heparin protocols. Example number 1. We have a patient who weighs 110 pounds with an order to start on standard weight-based heparin. The result of the baseline APTT is 29 seconds. This gives us a protocol order of a bolus with 80 units per kilogram, with our supply being 1,000 units per milliliter. We're asked to calculate the milliliters of heparin needed for the bolus and infusion. So our goal in this instance is to determine the number of milliliters in total. Our patient weight is 110 pounds, which will convert using our 1 kilogram per 2.2 pounds conversion. We also have the number of units here given as 80 units for every kilogram. We'll also need to include the supply that we have. So we have as our supply for every 1,000 units, we have a single milliliter of solution. So we have now our appropriate units canceling, pounds, kilograms disappearing, and even units, leaving us with milliliters. So with this computation, we should end up with a solution here of only 4 milliliters necessary for the protocol. Example 2. Here we have an order for heparin 75 units per kilogram over the course of an hour. The label in the solution reads 10,000 units for every 50 milliliters. The patient weight is 176 pounds. So how fast should the solution run to give the correct dosage? In this case, we're asked for a target of milliliters per hour, so a rate. So we know that we have the patient weight that needs to be converted, so it's 176 pounds converted to kilograms. We'll also need to include 75 units. So our heparin order here, 75 units per kilogram hour. So as we mark off some of our labels here, you'll notice that should leave us with the number of units per hour necessary. And so the last thing to consider is what we have as our solution. Our solution is given to us here as 10,000 units for every 50 milliliters. So how many milliliters do we need to accomplish this? So we want milliliters to be our desired unit at the top, and we'll cancel that out with our units by putting those in the denominator. So that should reveal to us the milliliters per hour necessary. And based on our computation here, we should get 30 milliliters per hour as a solution. So that is the rate at which we should set our infusion to give the correct dosage.